So hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So today in this lecture we are going to cover the third question from our DSA sheet, that is pattern wise, and here you can see that. So from 2 pointers we have covered 2 videos earlier, and today we are going to solve the third question, which is about sort colors. And if you don't know about this sheet, so this is called RB DSA pattern wise sheet. Here you can find the questions but not randomly. First we have filtered out 4 different types of patterns in array, and then you will find the questions on each pattern. And it is not only for arrays, I have done same for string, binary search, stack, TP, tree, linked list and everything. So if you haven't checked it out, I'll surely add the link in the description. You can check that and start solving with us. So here's today's question, name sort colors. It is available on LeetCode, problem number 75. Let's see what the question says. It says you will be given an array nums with n object colored red, white and blue. Sort them in place so that objects of the same color are adjacent with the colors in the order red, white and blue. So the question says we will be given 3 different colors, and these 3 different colors, red, white or blue, is represented by an integer 0, 1, 2. Our task is to sort them. Okay, you must solve this question without using library sort function. Okay, so very first condition is you can't sort, means you can't use the inbuilt function sort function here. Okay, if that was not a condition, you surely know that you have to sort it so that 0 comes first, then 1 comes, then 2 comes. And if that is the case, you can use inbuilt sort function and you can sort it. But here is the condition, you cannot use that. Okay, so we cannot use that. And let's see the constraint. Constraint is around 300. If we would have sorted, so you know by default the sort function, inbuilt sort function time complexity is n log n, and here it will surely work. But still the question says you don't have to use sort function. Okay, so let's come on to the screen. So here is what the problem is, sort colors. So what will be the output for this? Let's see this. We have to put like 0, 0, 0 first. So how many zeros were there? 1, 2, 3. Okay, so we put 0 first. And then we have to put 1 first. How many ones are there by the way? 1, 2, 3. 1, 2, 3. Okay. Now we have to put 2's, correct? So how many 2's are there? 1, 2 and 3, correct? We have 1, 2, 3. This is how it will be sorted, correct? But wait, what we did just now? We counted 0 first, then inserted in our answer array or override the same nums array. Then we count 1, inserted in the nums. Then we count 2, inserted or override 2. Okay, so don't you think we can write this in the code form as well? Yes, we can. Okay. So I think we have found what we have to do here. So just how what we did, we counted 0. So we will take a count 0 variable, we will take count 1 variable, and we will take count 2 variable. Okay. So we found 3 count 0, 3 count 1 and 3 count 2. So as of now we are just doing the brute force approach. Okay. So we have counted this count 0, count 1 and count 2. How can we count it? We can surely run a for loop for int I is equal to 0 to I less than n and I plus plus. We can run a for loop and we can simply check if our nums of I is equal to 0. Means we have to do what? Count 0 plus plus. Similarly, else if nums of I is equal to 1, we have to do count 1 plus plus. And similarly else what? Count 2 plus plus. Okay, so by running this for loop for one time, which will take surely O of n time complexity. Why? Because for every I we are running, because I we are running from 0th position to n minus 1. Okay, so it will be O of n time. So it will run for O of n time, and in the same time we can calculate ki how many zeros are there, how many ones are there and how many 2's are there. So one for loop we run to count it. Okay. After that our task is to overwrite it. So we can simply run the another for loop again. So let's run the another for loop for int I is equal to 0, I less than n and I plus plus. So what we are doing? We just counted all these 3 variables, and now what we will do? Until we have count 0, we will overwrite the nums of ith position, all ith position till count 0, convert it to 0. Okay, so I think for that a while loop will work. Okay, so we will run the while loop while what? Count 0 is greater than 0. Okay. Okay, now our task is to override the nums of I. So now for I also we have to run this int I is equal to 0. So nums of I is equal to 0. We have overwritten this. So basically I am saying this I pointer will take care of all the positions entire the nums array, and this count of 0 is nothing but ki how many times we have to run the I to override with 0 values. That's it. Okay, so we will convert this. We will do I plus plus and we will do count 0 minus minus. Okay, but why we did this? Initially our I was here, correct? Our I was at 0 position and count 0 is 3 times. So basically we will go and override with 0. Okay, let's override this with 0. Override with 0 and now I will be moved to this position. Now count 0 will be decreased from 3 to 2. Now again here we will check if our count 0 is positive. Yes. So nums of I we will put it with 0. So again we will override this nums of I with 0 and we will move this I plus plus, correct? So I will be moved from this position. So now we will again decrease the count 0 and it will be 1. Now again our task is ki do this, override this with 0. Okay, although it is 0 but you can put a if check also if it is not 0. By the way, anyhow the while loop is going to run for count 0 times for sure. Okay, so we will override this. So basically we will override this with 0 again. Now again our I will move from this position to the next. So I will move here and count 0 will become 0. Okay, now we will see in while loop is our count 0 is greater than 0? No, means we have inserted or overwritten all number of zeros in our nums array. So here's what we had 3 zeros initially and we have inserted or overwritten all 3 zeros. Now what's the task? Yes, the task is run the while loop again. I will be pointing to the same position it is pointing to currently after putting all zeros, and now we will run the while loop for how many times? Count 1 times. So we will basically write this same while loop now for count 1 greater than 0, and similarly we will do same thing now, but instead of I we will override with 1. We will do I plus plus and we will do count 1 minus minus. Okay, so similarly we will end up overriding these 3 values with 1 1 1. Now again we will run the same while loop for count 2 and we will end up overriding this with 2 2 2. But if you see more clearly, what is the time complexity in this case? The time complexity is O of n to count all 3 variables, and then you have run 3 while loops, correct? One for 0 count, one for 1 count and one for 3 count, and if you will sum it all, it will be nothing but O of n, correct? Why? Because this while loop we are running for 3 times. Now for count 1 you are running for 3 times. Now for count 2 also, because the count is 3, you will run for 3 times. So total you are running for 9 times, and 9 is nothing but the length of the nums. So in total the time complexity in this case is O of 2n, which is nothing but O of n. But still it is greater than O of n for sure, correct? Logically it is. So if you will write this code, this will run for sure and it is fast, no doubt. But if you will see the question, it says the follow-up, could you come up with a 1 pass algorithm using constant extra space? Okay, and 1 pass algorithm. So in this logic where we have taken 3 different variables to store the count of 0, 1, 2, we have run the time complexity is O of n. But if you will see this more closely, 1 pass you have taken to calculate the counts of all variables, and then 1 pass again you have taken to overwrite. So you have taken 2 passes here, and the question says can you do with 1 pass here? Let's see. Now let's discuss the more optimized solution, which is for 1 pass, means exactly O of n. So let's write the input first. So here is our input and our task is to sort it without using sorting algorithm. So whenever we talk about more optimized way, we always thought about the patterns here. And inside the array, we have learnt about 4 different patterns, which were, the very first was 2 pointers, second was sliding window, third was prefix sum, and fourth was cadence algorithm. And you know that for sliding window, prefix sum and cadence, we apply this whenever we need the continuous subarray, summation, multiplication or whatever, but we do the operation in the continuous subarray window. But here we don't have to take care about any window, correct? So blindly we can go for 2 pointer approach here. Yes, we can. And if you don't know about this, we have already discussed all these 4 patterns in detail, when to apply what, in our very first lecture of the playlist. If you have not watched it out, I'll surely recommend you go and check that out. But if you understand why in this question we will not apply sliding window, prefix sum and cadence and go with the 2 pointers only, then you are ready to go here. So now let's go with the 2-pointer approach. And with the 2-pointer approach, we are actually going to use the Dutch national flag algorithm to solve this question in just one pass. But don't be scared by the name Dutch national flag, okay? This DNF algorithm is so easy if you understand this with peace and calm, and if you are going to watch this video till the end, then I can promise you that you will surely understand in just one go. Okay, so here we are going to make 3 pointers. 3 pointers, okay. 3 pointers, so very first will be low, second will be mid and third will be high. Okay, so low, mid, high, 3 pointers we are going to put. Okay, and these 3 pointers, first will point to 0th index and mid will also point to 0th index. Remember that. And this high, this will point to last index. And all 3 went in a meeting and they talked ki who will take care of what element. Okay, so low said from 0 to low minus 1 position, I will take care of all zeros. Mid says from low to mid minus 1, I will take care of all ones. And high says, okay, from high plus 1 to n minus 1, I will take all 2s. Okay, wait, but how does it looks like on a number line? Let's see. After sorting, this is how it will look. 0, 0, 0, all zeros will be here, then 1, 1, 1 and then 2, 2, 2. Okay, so let's see where all these pointers will point to. So from the definition, low says ki I will have all zeros till low minus 1. So don't you think low will point to this position? So that definition falls true, because from 0 to low minus 1 I have all zeros. Correct. Now mid says from low to mid minus 1 I will have all ones. So low to mid minus 1. Mid minus 1 till here means mid will point to this position. Correct. So mid will point to this position. Now it says high says ki from high plus 1 to n minus 1. So n minus 1 is this position. High plus 1 will be this. So for sure high will be this. Correct. So high will be this. Okay. And if you remember, low started from left side and high started from right side. Means this mid and high will cross each other. Until that, the condition, the while loop will keep on running for sure. Because mid started from left side and high started from right side. And as per the definition, it's very clear that mid and high just crossed each other. And the while loop will stop. So for sure in the while loop, the high and mid will go. With a condition, while mid less than high. Because after that, when it crosses, we will stop. So condition will be while mid less than equal to high. Because till equal to also it would have run, then only it crossed each other, na? For sure. Yes. So that's the definition. Initially low and mid start together. So mid is the main party here. Means mid will decide ki what is the number there. In the meeting it has been decided ki whenever mid will find 0, it will pass this 0 to the low. And then low will also increment to next point and mid will also increment to next point. Let's clear this out in a fresh page. So here's our nums arena. So we can see this ki low and mid. Low and mid started from the same position and high started from the n minus 1. Okay. And in a while condition, we just saw ki mid and high will cross each other and then while loop will stop. So in the while loop, we will write ki while mid is less than is equal to high, till then the condition will run. Okay, so mid is running, high is running. So on the mid will decide, like mid will be running and checking which number it is. If it is 2, it will give it to high. Okay, so mid will run and go and it will say if it is 0, it will go to low side. If it is 2, it will go to right side. And if it is 1, mid will keep it with itself. Okay, so that's the definition. Simple definition. So we will run the mid pointer from initial position and it will say, hey, what is your number? What is your value? So mid will get this 1. And mid will say, ki, okay, this is 1. So this is my value. So I will not give low or I will not give it to high. Okay, remember that. Okay. So here in this condition, what is mid value? So mid value is 1. So means I am saying if nums of mid value is equal to 0, we will do something. I don't know, we'll discuss it later. Else if nums of mid is equal to 1, then we will do something. So initially what is the mid value? Mid value is 1, and what we have decided, if it is 1, mid will say I will keep it with myself and I will move alone. Okay. So mid will say I will keep it with myself and mid will move alone. So mid plus plus, simple mid plus plus, correct? Okay. Now in this case mid will move ahead. Let's see what happens. Again mid will say am I less than high? Yes, I am less than high. Then mid will say hey, what is my value? Is it 0? If it is 0, I will give it to low. If it is 2, I will give it to high. And if it is 1, I will keep it with myself. Okay. So mid got 1. So again, it will keep it with itself. So in simply again, mid will increment it to another position and mid will be plus plus. Okay. So now it is pointing to 0. Okay. Again, the while condition checks and it passes. Yes, mid is less than high. Now it says, hey, I am 0. And this 0 should be given to whom? Low or high? Low. So this 0 will be given to low position. Yes. And if this 0 is given to low position, so whatever is present at 0, 1, it is given to which? Mid says from 0 to mid minus 1, it will be sorted. High says from n minus 1 to wherever high is, it will be sorted. Means what is the unsorted part? The unsorted part is from mid to high. Yes. Yes, from mid to high it is unsorted. Correct. Okay, so let's write it somewhere first. Unsorted part lies where? Okay, mid to high position. So now here we found ki okay, mid value is 0, so this 0 will be given to low and whatever present at low it will be given to mid. Okay, so we will swap this basically. So we will write nums of mid and we will give whatever present at nums of low. And that's 1. And now our task is to swap. So at nums of mid we put whatever was at nums of low, which was 1. And now we have to put at nums of low. So nums of low we will put whatever is at nums of mid, and that is nothing but 0 because we just found nums of mid is 0. Simply write it with 0 also. Okay, 0. Okay, so if that is done, now we have swapped it with 0 and 1, correct? And it is still sorted. If you will see, it is still sorted 0, 1, 1, right? So it is sorted now. So now if that task is done, what low said, ki from 0 to low minus 1, I will keep 0. If you remember this point, see, from 0 to low minus 1, I will take all zeros. Okay, so for according to the definition, low should move ahead so that it will hold the definition keys from 0 to low minus 1 it has, correct? Okay, so mid said from low to mid minus 1. So to hold that mid minus 1, mid also should move to next, correct? See here, low to mid minus 1, it was having all ones. So low will come here and mid will come here. Low plus plus and mid plus plus, correct? Let's move this. So low will point to this and mid will point to this. Mid will point to this, correct? Done. Okay. Now it will say, hey, now mid will say I have 2 and this 2 should be given to what position? High position. Although it has 2, but we don't take care of what high is holding. We will just take care of what mid is holding. So mid value is 2, so mid value will be swapped with each other. Okay. Now, do you think mid should move ahead? Do you think mid should move ahead without checking ki what is the mid holding currently? No. Correct? No. So that is my condition ki when mid is having 2 value, after swapping now, only high will move behind, because from the definition high said ki from high plus 1 to n minus 1 I will have all 2's. So from high plus 1, so this position should be high plus 1. So for sure high should point to this position. Then only high plus 1 to n minus 1 will be holding 2's. Okay. So I said when in this else condition, when nums of mid will be holding 2, after swapping of what? Nums of mid and nums of what? High. Correct? After swapping, what I'll do? I'll simply do high minus minus, because high is moving from right to left direction. Okay? Done. Now what will happen? So now we have moved this high to high minus 1. Okay? So that's why we did high minus minus. Now when we put it whatever at high, we swapped with the mid position, but we don't know what is that. Correct? So we again have to check this mid. So that is why this will go in the while loop again, and then this mid will be checked with, is this mid 0 or is this mid 1 or is this mid 2. So again this will say, hey, I still have 2. So this will be swapped with this high. So now this high will be swapped with 2 and this mid will be overwritten with 0, whatever at high then. Now again this high will be moved only and this mid will be kept at the same position. Why? Because now mid is having 0. So now it has to decide now ki where it should put. That is why we will not touch the mid location. We will only change the high location. So again we will move this high here. So now by the definition we can say ki yes, from high plus 1 to n minus 1 we have all 2's because we have decided this one, and till mid minus 1 from low we have 1, correct, and from 0 to low minus 1 we have zeros. Now again after this high minus minus positioned at this location, we will again go there and now check if mid is 0. Yes, currently now mid is 0. So whatever at the low, it will get swapped and both will be moved, because for sure whatever low is holding, that will be 1 if it is getting swapped with mid. That is why we are moving both mid and low. But when it was swapped with high, we never knew ki what is that high index holding. So that is why we have to wait and again check in the while loop ki hey, now what mid value is having. Okay. So now after swapping, we can say ki low will be swapped with 0 and mid will be swapped with 1. So it is becoming so messy. So let's change it. Directly I can write this with 1. Okay. And this low with 0. Now I am saying this mid will move 1 pointer ahead. So mid will point to this and low will also move to this. So if you can see till mid minus 1 everything is sorted. Yes, it is 0, 0, 1, 1. Yes, it is sorted. And from high plus 1 to n minus 1 it is sorted. Yes. So the unsorted part is from mid to high. Yes. Yes, it has not been filtered out. Okay. Now again we will do this low plus plus, mid plus plus, we did. Now again it will check with the, what is the mid having? Mid is having 0, it will be swapped with low. So now low will have 0 and this will have 1, correct? Correct? Okay. So this is, low will have 0 and mid will have 1 after swapping, correct? Done. Now again I will move this mid ahead and this low ahead, correct? Now again mid will check, hey, what is the value I am holding? So it will say I am having 1. So when mid was having only 1, it just moved ahead. It did not swap with any 1 because mid is supposed to keep the 1 itself, na? So that is why. So now mid will move ahead and now mid and high will point to the same index. Yes, mid and high will point to the same index. Now it will say ki hey, mid is having 2. So mid is having 2. So what we did, when mid is having 2, we swapped with mid and high. So anyhow it is pointing to the same. So swapping doesn't mean we will do high minus minus. Now if we will do high minus minus, so high will come here and then we can say ki in the while loop mid has crossed high and we will come out of this loop. And at the end we have got all the nums array sorted. And what is the time complexity here? So if you will see, we just moved our mid pointer and we swapped. So for every swapping we took only O of 1 time complexity. So O of 1 for this, O of 1 for this, similarly, correct? Okay. Now we have moved the mid from left to right and we have moved the high from right to left. So what is the total time complexity? And we are waiting for mid to cross high. So in total, don't you think we actually wanted our mid to cross n minus 1, okay? But at the same time, high was also moving from right side and low is also moving from left side. So can I say ki if mid has moved x distance, so high would have moved total n minus x distance, correct? And in total the while loop has run for this, so total x plus n minus x, so O of n time complexity. So hence this code will run in just one pass. So let's write the code for this now. So first we will calculate the length nums dot length. After this we have to make 3 pointers, correct? So we will make 3 pointers like int low is equal to 0, mid is equal to 0 and high will point to what? High will point to n minus 1. Yes. Now in the while loop what was the condition? Condition was while mid does not cross our high, correct? Done. Our task is to check if nums of mid is equal to 0. Okay. Else if nums of mid is equal to 1 and else it is 2. You remember if it was 0. So what we did? We swapped it with the low one, correct? We swapped with low one. So what we did? In position of nums of mid, we have to put what is there at nums of low, correct? And at nums of low, we have to put what? 0, because that's what present at mid. Okay. And after this, we have to do mid plus plus. Why? Because we are done with this mid and low, so we will move this ahead. In case of nums of mid is equal to 1, we are not supposed to give to either low or high. So we will simply do mid plus plus. Okay, no swapping needed. In else case, when it was 2, mid is supposed to give that 2 to what? High. So we will simply write ki nums of mid. We will put whatever there at nums of high. Correct? Okay. And what we did? At nums of high, what we will give? Whatever is there at nums of mid. And as we fall in the else case, means nums of mid is 2. So we can simply give 2 and we will do high minus minus. Done? Okay. Now we are not supposed to return anything. That's it. So let's run this. It has passed. Now let's submit this. It has been submitted with 100% because that is the most optimized solution in just one pass. So here was the solution for Java. And here is the solution for C++. Let's run this also. It has been passed. Here is a solution for C++ and here is a solution for Python. With the same approach and same concept, this is the most optimized way. So I hope all the brute force 2 pass and 1 pass with Dutch national flag algorithm is clear. I hope this video was helpful. If it was, do let me know in the comment section, because your like, comment and of course subscriptions matter a lot, because that gives me more motivation to make videos for you all. And that's it. I hope it was helpful for all the coding language background, either it was Java, C++ or Python. And with this, we can mark our third question, sort colors, and we are done with this. I hope you are following this pattern-wise DSA sheet. If not, then I have already added the link in the description. You can check it out. And in the next video, we will solve the next question, which is move zeros. So stay connected and stay tuned. And if you like this video and found it really helpful, then don't hesitate to share with your friends as well. And also, I am available on Instagram and LinkedIn and other social media platforms, for which I have added the link of all my social medias in the description. Let's connect there. And that's it for today. Let's meet in another video with some more interesting topic and questions. Till then, keep learning, take care of yourself and your family too.